So again, we're asked for the same question, worded in a different way, but find the derivative with respect to x of this function f of x. So that's still same thing. Find f prime, find this derivative, find the slope function. Okay, so we write down the definition and apply it to our particular function. In this case, we have a cubic. So f of x plus delta x is going to be x plus delta x quantity cubed minus x plus delta x. And then we subtract off the function, which I'm going to put in parentheses, so remember to distribute that subtraction sign. And all of this is over delta x. Now we have expanded out a cubic already in this unit. In fact, the first problem we did asked you to expand out a cubic. So this is right here, this is x plus delta x times itself 3 times, right? So it's a bit of a beast to expand out. But again, I'm not going to ask you to do this on an exam, but for the purpose of note-taking, this is not an unreasonable thing. So we get x cubed plus 3x squared times delta x plus 3x delta x squared plus delta x cubed. For those of you that know anything about expanding binomials, these coefficients, the 1, 3, 3, 1, follow the order of Pascal's triangle, if that means anything to you. So there's sort of simple ways to quickly expand out binomials. So if I wanted to raise this to the 4th power, 5th power, etc., there's quick ways of doing this. You don't have to worry about this. We're not going to have to cube on the exam, but for our purposes, I want you to see this for note taking. Okay, so I'm distributing. Okay, so here's our function once we've expanded it. Let's look for some common factors, common terms, I mean. Sorry, not common factors. Like terms. That's the word I was looking for, like terms. So we have x cubed and negative x cubed. What else do we have? Look for it. See if you can find it. We've got a negative x and a positive x. I think that is it. Yes, I think that's it. Okay, and so now what I want to do is note that all of the terms that I have left, so this term, this term, this term, this term, all of these have them, right? So I want to factor out that delta x and be left with 3x squared plus 3x delta x plus delta x squared. And don't forget this guy. When you pull a delta x out of a negative delta x, you're left with a negative 1. Okay, don't just lose that term. Okay, and if it was just a plain old delta x, you'd still be left with a plus 1. So don't lose a term when you're factoring out. You should, if you started with 1, 2, 3, 4 terms, you better still have 1, 2, 3, 4 terms. Okay, as usual, we now can cancel out our delta x, but only because we wrote our limit carefully. So we have, oops. Sorry about that little error. Okay, so we're left with the limit as delta x goes to 0 of what was left here. And now as we let delta x actually be 0, right? These two things are both 0, and we're just left with, and I'm no longer writing the limit because I applied the limit. I'm left with 3x squared minus 1. So f prime of x is equal to 3x squared minus 1. Okay, number 18, explain the connection between the definition of the derivative and the notion of slope as rise over run. Honestly, at this point, I really hope you already know the answer to this question. It's appeared in a few of these videos and class. So when we think about the definition, if I look at this definition before I cancel out the x's, this literally is the change in the y coordinates, I spelled that wrong, whatever, or the rise over, down here I've got the change in the x coordinates, the run. Okay, so if I haven't made this clear yet, I hope this is clear now, that this definition of the derivative is really truly just rise over run when we're finding the slope between 2 points that are sort of infinitely close to each other. The original point x, f of x, and then a point that gets just slightly away from it, but then we let delta x go to 0. So these 2 points become the same as we apply the limit. That's how this turns from the slope of a secant line to the slope of the tangent line. But this really is just rise over run.